class, I want to talk about projectiles today and orbits. Okay, so first of all, to define projectiles, any object which can be thrown or launched and it has no means of propulsion. Okay, so if I throw an object, that is a projectile. Once you let go of it, okay, the only forces acting on it are, of course, gravity, which is pulling it down. Okay, and then there's a little bit of air resistance or friction, okay, but it's got an original velocity or momentum, okay, Newton's first law, of course. It's going to continue that straight line, but gravity, of course, pulls it down, and it gives it a kind of an arc-like shape, or they technically call that a parabola, right? So a projectile, when it's projected, it'll have a horizontal velocity, which is a velocity which is parallel to the ground, okay? And it also have that vertical velocity, which is caused by the force of gravity. Okay? So to show that, give an example. Here I have a guy in a tree with a little blowgun, okay, like a little blowgun, dart gun. And here is what somebody he's shooting at. Okay? So he lets that, blows on that dart gun. The dart's going to come out and follow this path, which is going to go something like that, okay, where it's got, of course, a little bit of air friction forcing it back, okay, opposing motion, okay, that's friction. Of course, it's going to have this force of gravity forcing it down. Okay, so it'll come to the ground there. Okay, okay, so once that dart leaves the barrel of the dart gun, if this person sees it, okay, he may drop out at the same time. Okay, think he's going to get avoided because he sees that dart pointing straight at him. He says he wants to avoid it, so he drops down. That's not a good decision. So if he leaves at the same time, okay, they're both being acted on gravity by the same amount, so they should intersect here, and of course that would be a hit. All right. So here's another kind of example I kind of like to show. You took a person, okay, on the top of the earth, which is unrealistic, with a gun. Of course, if he shot that gun, okay, the bullet would come out, and of course it would drop to the earth. Okay, but if he got a more powerful gun, okay, it would go a little further out, drop to the earth. But if you got a powerful enough gun, it would go further and further. You could theoretically get a gun which would fire a gun, and then as that gravity is pulling it down, it's got enough horizontal velocity, or we call that momentum, okay, which would make it go here, and it actually could, this is in theory, go all the way around the Earth and hit him, okay? So that's the idea behind what we call orbits. So any sort of orbiting body, so if I put the, say the sun here, okay, of course the sun's the most massive object in our solar system. If I put the Earth over here, not drawn to scale, just put an E there for Earth. Well, what are the forces acting on it? Well, Earth's being pulled into the sun, okay, by the force of gravity in that direction. That force to this center of the circle, that's actually called a centripetal force. Okay, so a force that causes an object to accelerate to the middle of a circle. Okay, but of course you know the Earth does not fall into the sun, okay, because what we have is a momentum. It's always taking us out at right angles to that. Okay, we'll say momentum for that. Or if you think back to Newton's first law, we have that certain inertia going that way. Okay. Momentum is actually equal to, it's given this little symbol like that, almost like a P, mass times velocity. Okay, we'll get to that a little bit more later on. Okay, but we only have the force of gravity forcing it back in. There's really no friction out in space, and so it's a vacuum of space, so it's essentially friction-free. Okay, but momentum is taking us out this way. So our original momentum for when the Earth was created does that. Okay, so we have a force in, momentum this way. So what actually that does, you get something in between, which is an orbit. Okay, so it'll continue to go around the sun. Okay. The moon does the same thing with the sun. Moon's out here. Okay, Earth's pulling in. Okay, moon's got an original momentum that way, so it goes that. Okay, so actually, if you trace the moon as throughout the year, it would be making circles like that around the sun. Okay, this goes for any orbiting body. Okay, so like a space shuttle which orbits the Earth. Okay, you have the Earth here, and you have the space shuttle out here. Okay, about 120 miles up, I think, about 200 kilometers. Okay, Earth is pulling it in, but it's got what they call escape velocity to get out here. So it's got a velocity which is taking it out here, and it results in an orbit. Okay, and because it's always getting pulled in, okay, the gravity's pulling in, those astronauts are in a free fall. So you can see those astronauts. The astronaut steps out of the cargo bay there, and it's like this. Okay, Earth's pulling him in. Okay, but since he was on that ship when he stepped out, he's still got that momentum taking him that way, so he'll just fall around the Earth, okay, and continue. So if that astronaut somehow got disjointed from the space shuttle, something happened, he would just stop floating in space. You could have that astronaut just kind of floating around there, okay, for eternity. All right? So there's orbits and projectiles.
It's flying at a constant horizontal velocity.
Vertical velocity is
Changing because of gravity.
That's right,
So gravity's slowing it down on the way up, and then gravity's speeding it up on the way down.
once it leaves my hand, there's only two forces on it. One is gravity, and the other is
Air resistance. But the shape of the football is pretty aerodynamic.
aerodynamic to decrease the friction.
I got a big one. Alright.
Okay, we just talked about orbital motion. Okay, so this would be an effect on things orbiting bodies like satellites. Okay, so the sun and the Earth's relationship. Okay, sun's at the center. Its gravitational pull is pulling the Earth in. Okay, and of course, the Earth is not being pulled into the sun just because it's got initial momentum. Remember Newton's first law, wants to go out and just keep going in a straight line. So in this case, I'm the sun, the blue Earth here. Okay. Gravity is pulling towards the center, and that's represented by the rope. That's called a centripetal force. Okay, now if I let go of this right as it's pulling towards the camera, okay, it's not going to go to the camera, but it's going to go at right angles to that. So I'm going to try to let go of it right when it's at Mr. Ford's head. 1, 2, 3.
Thanks for not hitting me.